So we're going to talk about something called fractional exponents today. So we're going to talk about exponents where the exponents are some fractions. Question?
Wait, this doesn't have a lesson number?
FE, 12 FE. Yeah. So let's remember this. You guys remember if I have 2 to the third times 2 to the fourth, what do we do with the exponents? Yeah, you add them together. So you get 2 to the seventh. You guys remember this? So if this is true, with this example, if this is true, can you then do this example? Here, I have 2 to the n times 2 to the n equals to 2 to the first. Find n. What would n be? Go ahead, everybody try. Knowing the rule for exponents, when you multiply them together with the same base, you add the exponents. What do you think n must be? I'll give you time. Oh, some of you have the answer. Okay, talk to your group. Go ahead. See what you get. So, I heard, okay, time to listen now. I heard some of you say, oh, n could be 1 and n could be 0. How about 1 and 0? 1 plus 0 is 1, right? Can we do 1 plus 0? Why not? Yeah.
Because they're both n. They're not
Yeah, you can't. They're both n. They have to be same. Who has the answer? Andrew?
N equals half.
Half is correct. If it's half, right? If n is half, look. Like 2 to the half. I could actually write it down right here. 2 to the half times 2 to the half power, I mean. Right? Times 2 to the half power. What do you get? 2 to the half plus half. What is this? 2 to the 1. Is that what we get? So you could actually do this algebraically. Isn't 2 to the n times 2 to the n, isn't that 2 to the 2n?
Yeah.
Doesn't that have to equal to 2 to the first power?
Yeah.
So if the left side is equal to the right side, guess what? 2n must equals to 1. Now if left side equals to the right side, doesn't 2n have to equal to be 1? Right? So you do a little, you could do this work algebraically. Yeah, you divide both sides by half, and you get n equals to half, right? Does that make sense? So, right, because left side is equal to the right side. We just look at now then, since we have the same base, you just look at the exponents, right? In order for the left side to equal to the right side, they have to have the same exponents. Now if this is true, what does 2 to the half power really mean then? So this is what we got, right? 2 to the half power times 2 to the half power, we got 2. By the way, is 2 to the half power same number as 2 to the half power? Are these two numbers same numbers? Yeah, we don't know what they are yet. But yes, they are the same number, aren't they? Now, what do you think? So it's just, what do you think 2 to the half power means? Some of you got it. You want a hint? When you multiply two numbers that are same, is there a way to get 2? Same number times same number gives you 2. Is there such number? Square root of 2. Right? Isn't square root of 2 times square root of 2, doesn't that give you 2? So, if this is true, if 2 to the half power times 2 to the half power equals to 2 to the first, and if square root of 2 times square root of 2 equals to 2, guess what 2 to the half power represent? Square root of 2 is exactly right. Okay, so we get there. So isn't that right? 2. So by this example, right? 2 to the half power must be square root of 2. Are there any other numbers other than square root of 2 that you could plug in for 2 to the half power? In other words, are there any other number other than square root of 2 that you could use? No, there's only one. So that's what it means. Square root of 2 means 2 to the half power. Or 2 to the half power means square root of 2. Okay? Question?
So if you do like 25 to the half power, would it be 5?
Exactly. 25 to the half power would be 5.
Good job, Matt.
Right? Because that little exponent 1 over 2 really means, now we know what fractional exponent represent, right? It means square root of that number. Now, do you guys remember invisible 1?
Yeah.
We don't normally write x to the first power, do we? We don't normally write 1x, do we? Well, you're supposed to, but people got tired of writing that. They just don't write. Like, if I have 2 minus 3, you know, it was really 2 plus negative 3, right? They don't use, you know, they don't put that. So same way, same thing happened here. Square root of 2, you're missing. They got tired of writing square root of 2 the correct way. They just write it this way now. The correct way that they're supposed to write this is, anybody know what the correct way is? So you know how like x is really x to the first power? No, it's actually, yeah. No, it's this. That little 2, guess where that 2 comes from? Where? What's that thing? The denominator. Okay. So that's where, so you're supposed to write square root of 2 this way. People got tired of writing that little 2, so they got rid of it. So if you don't see one, okay, that means there's 2 there. So we found invisible 2. So just like invisible 1, there's invisible 2 too. So on this one. Well, that's what it's supposed to be. Because of this denominator, to indicate that this is 1 over 2, that 2 comes from that denominator. So when you use square root sign, you're supposed to use that 2 there. But people got tired of writing it, they just got rid of it. Yeah, question?
So I'm confused. So we have 2 to the half is equal to 2 squared. So
2 to the half equals 2 squared?
no, 2 to
Square
the
root
1 half. No, 2 to the 1 half is equal to rad 2.
Yes?
Is it just saying there's like an invisible 2?
Yeah, there's invisible 2. You're supposed to write 2 here. They just don't write it. So if you don't see anything there, you know that it's 2. Does that make sense? Yeah.
Is there a way that you could show that 2 to the half power is equal to like square root of 2 like algebraically?
No, this is just a notation. They just, yeah. So, yes.
I don't really get like why is a 2 there?
You still don't get why there's 2?
Yeah.
Because, let me explain why. Can you do this one? So let me write this down. Is that okay? It's the same as well. So if I have, I don't have to have 2. A to the any half power, it means square root of a, which is the same as 2, you know, square root of, that 2 is right there, right? So that's, I'm just telling you. So you still don't know why there's 2. Okay, so why don't you try this one? Everybody try this one here. 4 to the n times 4 to the n times 4 to the n equals 4 to the first. What do you think this n is? Go ahead, everybody figure this out. And Cameron, hopefully this example will show you why that we need 2 really. Okay. Go ahead. Oh, you guys already got this? It's what? It's easy, yeah. You're right. It's what? 1/3. Why is it 1/3? Well, because you get 4 to the 3n power, don't you? And you multiply 4 to the n times 4 to the n times 4 to the n. But it has to equals to what? That exponent must equal to, yes? No, so what does that 3n has to equal to? If the left side is equal to the right side, it has to equal to 1, right, Talene? Okay, can you put the backpack down? Because I don't know what you're doing there. So then, Talene, what do I get? You divide both sides by 3, so you get n equals to 1/3, correct? By the way, don't use your phone during class, right? Then, when you do this, so let's verify. N is 1/3, so that means, let's check. Isn't 4 to the 1/3 times 4 to the 1/3 times 4 to the 1/3, isn't that 4 to the 3 over 3?
Yeah.
That's 1. Right? So Cameron, what do you think 4 to the 1/3 really mean? Well, let's go back. What did 2 to the half power really mean here?
Square root of 2.
Yeah, square root of 2, which means it's asking which same number can you multiply twice to equal to 2? Is that what it's asking? Square root of 2?
It would be like 4 and then like square root of 3.
Yeah, so hold on. So 2 to the half power really means is asking is square root of 2, right? So what does square root of 2 mean? Well, we're looking. What does this number when you punch this in the calculator? Okay. As a matter of fact, why don't you do that one? If you have a calculator, punch it in. What's square root of 2 equal to? It's about. Square root of 2 is about. What is that? Let's do it to the nearest hundreds. What's that about? What did you guys get? Square root of 2? Yes.
1.414.
Okay, how about 1.414? 1.41. Now, why does that equal to 1.41? Because if you do 1.41 times 1.41, guess what you get?
Almost 2.
Almost 2, right? So what does square root of 2 asking you to find? Find a number such that when you multiply the same two numbers, you get 2. Okay, guess what then? 4 to the 1/3
3 numbers.
means. Raise your hand, raise your hand. What do you think it means? Kobe?
I don't know what the number is, but it has
Right.
to be a number that like the same number like times 3.
Yeah, where did you get 3 from?
Oh, it's because there's 3.
Yeah, 300, yeah, 1/3, right? That's what, so it's asking, multiply same number 3 times and get equal to 4. And what is that number, right? It's got to be bigger than 1, right? Because 1 times 1 times 1 is 1. It's got to be smaller than 2. Turns out, when you can actually punch into a calculator. It comes out to be about 1.58. Okay. If you don't believe me, multiply 1.58 times 1.58 times 1.58. You get about 4. No, you don't have to give me the approximation. But I just want you to understand what number it represents. Yeah. Say it again. Can I simplify to square root of? Oh, that's a good question. So, questions? Okay, so I wrote this down. How come I have 3 right here? How come I don't have 2 anymore? What do you think I need that? Why don't I write 2 here? Cameron?
Because you're multiplying the same number 3 times.
Yes, this number represents you need to multiply same number 3 times to get 4. You see what I mean? So Cameron, do you see why we needed 2 there on the top?
Yeah, but then when you're just writing like regular square root,
Right?
like is 2 implied?
Exactly. When you write a square root, 2 is implied. That's why I'm saying this is really invisible. So if you don't see anything, you know there's 2. Because this 2 is telling the reader what same 2 numbers can you multiply to make it equal to 8. Does that make sense? Here, when you have that number 3, guess what?
3.
Yeah, we want to multiply same number 3 times so that it equals to 4. That's what it means. That's why we need that number, right? Out in that it's actually smaller than regular. So you will need to write it right above that symbol. Lara.
So 1.58 cubed is 4.
Yes.
Almost.
But almost. Because guess what? This number, cubic root of 4, is a irrational number. It's a number that goes on forever without repeating. So that's why I wrote down squiggly line here, right? That's an approximation. Hmm? Judy.
So if there's nothing in front of the square root, it means like there's always invisible too.
Yeah.
Nothing else.
Yeah.
But
But-
if there's other than 2, it will say.
Exactly. You have to, otherwise it won't make any sense. Yes.
So like you know how like we like factor numbers inside the square root,
Right.
and if they're like pairs, then we do like triples. Like,
Yes.
the triples
So
of
if
the
you
numbers.
if the number was like for those, yeah, exactly. So we'll get there in a minute. Any other question? Yes.
But if 4 isn't 4 a perfect square?
Okay, so somebody said, isn't this square root of 4? You were saying the same thing. Is it square root of 4 too? Do I have square root of 4 or do I have cubic root of 4?
Cubic root.
Because, yes, if I left this out, then yes, this will be 2. But am I talking about square root of 4? No, I'm talking about this new thing called cubic root of 4, which means 4 to the 1/3 power. Does that make sense? So do you think we're limited to just having that denominator to be 2, 3? Do you think we could have 4? Do you think you could have 5? Yeah, you could have actually. As long as n is not 0, you could have any numbers there. Okay? So a to the 1/n power means, this is how you read it, nth root of a. Does that make sense? So you have the square root, you need that number n right there, don't you? Does that make sense? Yeah, if you don't have anything there, that means you could assume that that's what? If you don't have this, it means what? 2, right? That's the invisible 2. Because we use that so many times, people got tired of writing that little 2, so they just wrote square root. Okay? So that means it's 2 there. Any question? Okay, go ahead and write it down. Okay, so if you understood that part, see if you can do this. Simplify these. I have square root of 4 equals to what number? Now this is cubic root of 8 equals to what number? This is now 4th root of 16. So for 3 it's a little bit different. For 2 is, you don't say 2 root of, right? Second root. So you say, I guess you could say second root, but we say square root, here's cubic root, and then here's 4th root of 16. Okay, go ahead and fill out. Go ahead, ask your group members and help each other out. What do you think goes into it? What are they asking? Go ahead. Okay, so let me ask you this one here. So the first one, there's the little 2. Do I have to have the 2 there? No. That's why it's invisible 2. If you don't see anything, you know by default it's 2. So it's asking, if you multiply 2 of the same number, how do I know it's 2 of the same number? Because of the 2. That's what that, right? So I need to multiply 2 of the same number so that I get 4. Is there such number? What is it, guys? 2. What's 2 times 2?
4.
What about this? What is this asking? It's asking how many times do you multiply the same number by?
3.
3 times. How do you know? That little number. That's why it's called cubic root. Okay, so you say, well, do you know such number when you multiply same number 3 times?
Yeah.
2 again. 2 times 2 is 4. 4 times 2 is 8. Now, what about this one? How many times do you multiply the same number by? 4 times. So is there such number?
2.
Yeah, 2 times 2 is 4. What's 4 times 2? What's 8 times 2? Now, some of you say, wait a minute, what if I didn't see that? What do I do? Guys, listen. What if I didn't see that it was 2? What should you do if you didn't see that? Yes?
You factor it.
You do a factor tree, guys. You could just do a factor tree, and you know that 16, when you do a factor tree, there are how many 2's? 4 of them. Does that make sense? Right? If you don't see that, you just do a factor tree. And you just see it. Yes? Do you understand? Yes?
Could it be like another number? Like for 9, it's 3 and 3. Would that still be the same?
If I have square root of 9, yes, it's 3. Is that what you're asking? Square root of 9 will be 3, but if you have cubic root of 9, it's not 3, is it? It's some irrational number. Okay? All right. So if you got that, then let's look at example 3. We're going to kind of do it backwards now. Oh, do we need more time? No? Does anybody need more time too? Okay. So we're going to do it backwards. It says, write each of these following radicals in exponential form. So we're kind of going backwards. You know how we had these in radicals? Now we change into, we're going backwards. So let's do A, B, C, and D. I'll give you time. So let's do A together. So A, if I have square root of 5, does anybody know how to write this as a exponential form, meaning with an exponent? 3 people? Oh, how about Caroline?
5 to the 1.
Yeah, 5 to the 1/2. Right, guys? So how would you then do this one right here? It says cubic root of 7. Anybody know how to write that? Judy? 7 to the 1/3. Exactly right. What about then next one? Fifth root of 2. Sure? 2 to the 1/5. You get the idea?
Yes.
And the last one. This one's interesting. Who thinks they know how to represent 7th root of negative 12? Aaron.
No solution.
Well, are we solving?
No real solution.
No. This is not an equation. So I know what you mean. Aaron, you mean undefined, right?
Oh, yeah.
We're simplifying, so you're not solving anything. So what do you don't even talk about solutions. You're just talking about, right? But why do you say undefined, Aaron?
Because it's negative.
But in this case, it actually is not undefined. Anais?
No solution?
Huh? We're not talking about solutions anymore. It's not an equation. Harrison, what do you think?
Oh my goodness. Undefined?
What? Yes, negative 12 to the 1/7. This is okay to have. Why is it okay? Because didn't we say something about, oh, you cannot have a negative number in square root? Do I have square root or 7th root? 7th root. Why? Lara, how come it's okay to have negative here? 7's an odd number. You're multiplying number odd times, so it's okay. Because if you multiply negative number odd times, don't you get negative? Now, what if I had 8th root? Then you will write undefined. Does that make sense? Don't write no solution. We're not solving anything here. We're simplifying. Okay. Any question? Yes. Yeah, because if A will be even, there's no way for you to multiply a number even times to get negative. But if it's odd, it's fine. You could have negative. Right? Do you guys get the idea? Yes? All right. So before I move on, let me remind you of this rule. You guys remember A to the n, the whole thing to the n power. Anais, do you remember what to do with these exponents?
Sorry, what were you saying?
If I have A to the n power, that's why you need to be paying attention, right?
You multiply m and n.
Yes, you multiply the m and n. You guys remember this? Now, do you guys remember these rules work for negative exponents? Do you think it'll work for fractional exponents as well?
Yeah.
Yes, it will. Okay, so let me give you some examples. Okay. So let me ask you this. What does 4 to the half power mean?
2.
Yeah. Haven't we done this many times? This is basically square root of 4. Isn't that 2?
Yes.
Now, 4 is 2 to the second power. So you could think of it as square root and the square cancel out. There's another way of thinking about this. Another way of thinking about this is you keep this as 2 to the second power to the half power. Why? That's a good question. Why do you think I would like to leave it as fractional exponents? Anybody see it? One person? 2, 3, 4. Owen, why? Why do I want to do this? Shh.
So that like when you do 4, like 2 squared is 4 and then
No, that's not the reason. Chansu, why do I want to do it this way? I can multiply now the exponents just like the fact that we had before. What is 2 times half? 1. We get the same answer. Do you see that? Okay, we need some time. Okay, go ahead and talk to your neighbors, see if they get this. Okay, go ahead, help each other out. So if you got that problem, what if I gave you this? Example 4a, it says to simplify a to the 1/3 power. Now, do you think it's a good idea to do a factor tree for 8? Okay, some of you see this already, but if you didn't, hold on. If you would do a factor tree for 8, how many 2's do you have? So isn't this 2 to the 3rd to the what power? 2 to the 3rd to the 1/3. What is this equal to? Is equals to 8?
Oh, no, because
What do we do with the exponents, Matthew? So what do you get? Do you get 8? 2 to the? Yeah, that's not 8, is it? You get 2. Well, we did this one before, didn't we? Right, guys? Didn't we do this one? What does 8 to the 1/3 power really mean? Cubic root of? No, 8 to the 1/3. It means cubic root of 8, which is 2. Right? You guys remember? We did the same problem. Yes.
What if we're like confused about like what if we like didn't know what the 8 was?
Right?
Or, like if it was like a different number and then we did a factor tree on it and we got like 2 to the 3rd and like 3 to the 4th.
Right. So for tonight's homework, they're gonna give you nice ones. When you get something like that, that's later. Okay, so don't worry about it. All right. So can you do something like this then?
yeah.
Try these.
oh, that's so easy.
Whoops. Okay, so this is equal to, we did this one.
Bro, it's too easy.
Good. Didn't we do that one? Cubic root of 8. Okay. All right, go ahead. Try these. B says 49 to the half power. Can you simplify that? C says 64 to the 1/3. D says negative 32 to the 1/5. E says negative 81 to the 1/4. Do you think doing a factor tree would be helpful? Go ahead, everybody try. I'll give you time. Help each other out, okay? It's not a test. All right, so here we go. Malia, the first one, 49 to the half power. I know that some of you already know how to do this in your head, but I want to see this kind of work on your homework. So what kind of work would you show, Malia? Yeah, do a factor tree for 49. What is that going to be? 7 to the? Yeah, 7 squared to the half power. Isn't that right, guys? Don't we get simply 7? Yes? Any questions? Easy?
Yes.
Question?
Can you like put it in the square root to like do that better?
Oh, you could do that, but it's easier to use as a fractional exponent rather than putting in actual square roots. Isn't that right? Because you want to multiply these exponents together, right? What's 2 times 1 over 2? You get 1. Same thing for this. 64. How many people did a factor tree for 64? What'd you get?
16.
It's 4 to the third. Don't you get 4 to the third? To 1/3. Now, did anybody do 2 to the 6th? Because it isn't 4 to the third. If you could keep going, right? So you get the same answer. By the way, what's this? 4 to the third to the 1/3. You multiply 3 times 1/3. What do you get?
It's just 4.
4. Or you could have done 2 to the 6th to the 1/3. What's that going to give you? 2 to the 2nd, which is 4 again. Same thing. Okay. Right? Are we good there? What about D? How many people did a factor tree for negative 32? By the way, is this okay to do a factor tree for that? Yeah. Sophia, what'd you get?
I didn't get it.
Oh, you didn't get that one? How about then Matthew? Negative 2 to the 5th. Very good. Did anybody put 2 to the 5th?
I just got negative.
Why would that be wrong? Yeah, guys, if you multiply positive 2 5 times, do you get negative 32? Of course not. That's why we need to put negative 2 to the 5th. Right? And it's negative 2 to the 5th to the 1/5 power. What do we do with the exponents? What's the answer, class? Negative 2. Questions? In other words, if you multiply negative 2 5 times, what do you get? Negative 32. What? No, I'm talking about D. Negative 2, if you multiply negative 2 5 times, you get negative 32. That's not undefined. Oh, what about E? Yeah, this is undefined. Okay. Because you cannot multiply, it's not on a number line, is it? Real number line. You cannot multiply a number, even number of times, and make it into negative. Correct? Guys, any question? Do you see what you could do for your tonight's homework? They get a little bit creative.
No. Is it really hard?
No. Here is how they get creative. You ready? Okay, I need your attention here. So, they give you something like this. But it's not that hard. What do you think? There are actually 2 ways to think of it. So, we do the same thing. For 8, do you think we're going to do a factor tree? What do you get when you do a factor tree for 8? 2 to the third, right? So, isn't this 2 to the third to the 2/3 power? Derek, what do we do next? Listen now, Kobe. Okay, hold on, guys. It's time to listen. Thank you. Go ahead.
Then you multiply the 3 and 2/3.
Which
and
is?
you get 2.
Yes.
So the answer is
Exactly right.
Miss
Is there? Hold on. Is there another way to think of this? Yes. What? 2 people? Kobe, what do you think?
Oh, I like how I thought of it at first. It was like cubic root of 8 squared.
Yeah, you could think of it that way, or actually, I thought of it the other way. I said, 8 to the 1/3 to the 2nd. Cameron, is that what you were gonna say?
Yeah, I was thinking like 8 to 1/3 plus 8 to 1/3.
Yeah, exactly. That's exactly what it is. So you could think of it this way too, isn't that right? Because 1/3 times 2 doesn't that give you 2/3? But don't we know what 8 to the 1/3 is? What is that?
2.
Because it's 2 to the 3rd to the 1/3. Same way it works. You get still 4.
I think the other way.
You like the? Yeah, I like this one too. So let me give you that method. So here's a fact. Write this down. If you have a to the mn instead of 1 here, if you have mn, guess what? It's just a to the 1 over n to the n power. Isn't that what it is? That's all it is. Right? Okay. But you could just keep it as, fractional exponents. It'll still work out. Does that make sense?
Yes.
Good.